In this example, we're supposed to add the polynomial 6x to the third plus 4x plus x squared minus 7 and the polynomial 2x to the third minus 8x squared plus 3. So since the operation is addition, when we set it up, we're going to put it in parentheses as 6x to the third plus 4x plus x squared minus 7. Since it's addition, we'll have a plus sign between the two sets of parentheses containing the polynomials. 2x to the third minus 8x squared plus 3. Since the operation is addition in between the parentheses really can just be ignored, and we'll focus on combining like terms. So my x squareds will be combined. They're both positive here, making us have 8x to the third. Now I'm going to look for x squared, so I have 1x squared here and minus 8x squared there. Combining them gives me negative 7x squared. Next we have 4x, so plus 4x. And then the terms without the variables, so here and here, negative 7 plus 3 is negative 4. And that is it. Okay, in this example, we're simplifying the expression. We have one polynomial minus another polynomial. Now, when we're subtracting polynomials, we have to distribute our negative 1 that sits in front of the parentheses. Anytime we have a minus sign in front of parentheses, we'll have that negative sign there that we'll have to distribute through the second set of parentheses. So my first set of parentheses here, my first polynomial, will not change. I'm just going to bring him down. But then we'll distribute negative 1 through the second set, making it negative 3x squared y squared minus 2x y squared plus 2x squared. Afterwards, we'll start combining like terms. With the multivariable polynomials, depending on what you're looking at, they may be in different orders. So I'm just going to start working from left to right. We got x squared y squared, so I'm going to look for other x squared y squareds, which is right there. So 4 minus 3 is 1x squared y squared, which is really just x squared y squared. In the next term, I have xy squareds, so I'm going to look for other xy squareds, which I have right here. So we have 5 minus 2, which is a positive 3xy squared. Remember, when you're adding and subtracting, exponents do not change. Next, I have a 4x squared. I also have a 2x squared, which gives me a total of 6x squareds after combining like terms. And it looks like I combined all the terms that I had. So this would be our final answer. So in this example, we are going to simplify this expression. We have 3ab times the polynomial 5a squared plus 3ab minus 2b. So because it's multiplication, we're going to be distributing the 3ab through. So 3ab times 5a squared. When we multiply these, just like normal, we'll multiply the numbers, giving us 15. But then when we multiply the variables, we will actually add their exponents. Remember that if it doesn't have an exponent, it's implied to be to the first power. So we have an a times an a squared, which will give me a cubed. And then we have the b, but the 5a squared doesn't have any b's, so we're just going to bring the b along. Now for the second term, we're going to do 3ab times 3ab. Multiplying the numbers will give us 9. And then for the variables, we have an a times an a, making a squared, and a b times a b, making b squared. And lastly, we have 3ab times negative 2b. Multiplying the numbers, I get negative 6. Only the 3ab has the a, but they both have b, so we'll combine them. B times b is b squared. You should check for like terms, and if we look, there are no like terms to combine, so this is just our answer. Okay, so we're going to simplify this expression here. We have the binomial 2x plus y times the trinomial 3x squared minus 7xy minus 6y squared. We'll have to distribute here. So distributing through, 2x times 3x squared is 6x to the third. Remember adding the exponents. 2x times negative 7xy, multiply the numbers, gives me negative 14. We have an x times an x, making x squared. And then we had that leftover y with the negative 7xy. Then lastly, 2x times negative 6y squared, multiplying the numbers, gives me negative 12x y squared. No variables are the same, so we can't really combine them. Now we're going to go back through with the second term of the binomial, y times 3x squared. Really nothing's going to change. We're just going to combine them here to get 3x squared y. By the way, it does not matter the order you write the variables in. I usually write them in alphabetical order. Y times negative 7xy. Well, the negative 7x won't really change, but we do have a y times a y this time, giving us y squared. And then lastly, y times negative 6y squared will make it negative 6y to the third. Then we just have to combine like terms. If I look through, x to the thirds, there are no other x to the thirds, so we're going to bring down 6x to the third. We have x squared y. There is another x squared y. Remember, x squared y and xy squared are different. Combining them, we have negative 14 plus 3 is negative 11 x squared y's. Then we have negative 12x y squared. We also have a negative 7xy squared. Combining them gives us negative 19 x y squared. And then lastly, my last term is just going to come down. And that's my answer. Just before going on, I know some people like to use the box method for distributing. You can do that here as well. Here would be the initial setup. You would set it up with one of the terms on the side, for example, 2x plus the y on the side, and then the trinomial along the top, 3x squared minus 7xy, and then minus 6y squared. Give a column for each term and a row for each term, and that would be the setup if you're doing the box method. It works very similar, and you still get the same result. Just maybe in a different order, depending on how you pulled it out of the box. Okay, in this example, we have three binomials multiplied together. We got 2a plus b times 3a minus b times a squared b plus 5. Whenever you have three things multiplied together, just like if it was regular numbers, for instance, 2 times 3 times 4, you would group two of them together and multiply those two first, and take that result and multiply it by the third one. So doing this works the same way. So going through, we will group the first two together and distribute those out. 2a times 3a gives me 6a squared. 2a times negative b is negative 2ab. b times 3a is positive 3ab. Again, I just prefer my variables in alphabetical order, but the order doesn't really matter for the variables. And then b times negative b is negative b squared. If I combine my like terms, I have these two as like terms, so we'll have 6a squared plus 1ab minus b squared. So that's the result of multiplying those first two binomials, and we'll bring down the third binomial, the a squared b plus 5. So now we're going to continue to distribute things out. So I'm going to do 6a squared times a squared b. So the number isn't going to change, but we do have an a squared times an a squared. Adding the exponents gives us a to the 4, and we have that extra b. Then 6a squared times 5, we'll multiply the numbers, giving us 30. No other variables with the 5, so the a squared is just coming down without changing. Next, we'll multiply the ab, distribute the ab through, so ab times a squared b. There's no numbers, so the numbers are both 1. 1 times 1 is 1, so no change with the numbers, but we will change the exponents. A times a squared will give me 3 a's multiplied together, and then b times b will give me b squared. And then we'll distribute ab times that second term in the binomial times 5, so we'll have 5ab. No changes with the variables because the 5 doesn't have any variables. And now we'll go through with the final term in the trinomial, the negative b squared. Negative b squared times a squared will be negative a squared b squared. Again, I could have wrote it as negative b squared a squared. I just prefer in alphabetical order so that it's easier to identify my like terms when I go to combine them. And then negative b squared times 5 is just negative 5b squared. I'm going to check to see if I have any like terms. I'm not sure if I do this time. We've got a4b, a squared. I don't see any other a squareds or a4's b's. It doesn't look like I have any like terms, so I think this is just it. I don't see any variables with the same exponents. So this just happens to be the answer. And you could have it rearranged in different orders, but this is good.